Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. For this question, it's really important that we understand what the words sum and product mean. Now, sum just means add, and product just means times. So we're going to start by adding the 5 and the 4. So that will equal 9. And then what we're going to do is find the product of 9 and 7. So we're going to multiply them together. 9 times 7, which is 63. So our answer is 63. For this question, we're going to have to remember BIDMAS or BODMAS. So we're going to first of all look and see if we've got any brackets. Well, we do. We've got the 11 squared minus 21 in brackets, so we're going to be looking at that bit first. Inside the brackets, though, we don't have any brackets, but we do have an indice. We've got that 11 squared, so we're going to deal with that first. So 11 squared is 121. So we've got rid of the indice, but we're still looking at the bracket. So we're going to do 121 minus 21, which is going to be 100. Now we have no more brackets, no more divisions, but we do have a multiplication. So it's going to be 300, and that's our answer. So we've got 10x plus 2x. Now 10x plus 2x are like terms, so we can just add them together to make 12x. And we've got that equal to 24. Let's put in our solve lines. Now that 12 before the x is a times 12. So to get rid of it, we do the opposite, which is divide both sides by 12. And so we've got x on the left-hand side and 24 divided by 12, which is 2. So our answer is x equals 2. So we're told the sequence starts at 20. So our first term will be 20. And we're told that the rule is add 5. So we're going to add 5 to that. And that would be 25 for our second term, add 5 again, and that would be 30 for our third term. Just like when you're simplifying fractions, you can't have decimals at the top and bottom. You can't have decimals at the top, at the left and right of a ratio. So we're going to have to get rid of this decimal. And the way we're going to do that is just simply times each side by 10. And that will leave 4 and that would be 60. Now we can simplify this further, because I can divide left and right by 2. So that would be 2 to 30. And I can actually do the same again. I can divide them by 2 again. And that would be 1 to 15. Now you might have just divided by 4, and that would also give the right answer. In fact, there's a couple of different methods that you can get the same answer with. So you do need to know the parts of a circle. So the full distance around the circle is called the circumference. If you've got a little bit of it, it's an arc. If you've got a line across it, that would be a chord. And the part that's kind of trapped in there is called a segment. Then if you've got a line across the circle going through the center, that's a diameter. If you've got a line just going to the center, if I can draw it properly, then that's called a radius. If you've got a line that touches the circle just on one point, like that, that's a tangent. But in this case, we have a sector. The first thing we need to do is work out what angle CBD is. So we're looking for angle CBD. And that's going to be 180 take away 170. And the reason being is it's angles on straight line. Angles on a straight line add up to 180. So that's going to be 10 degrees. So this will be 10 degrees. We then need to find out what angle CDB is. And this is obviously going to be 10 degrees as well, because it's angles in an isosceles. So this will be 10 degrees, and the reason will be that it's an isosceles triangle. And to find out what x is going to be, it's going to be 180 subtract 10 plus 10. And the reason for that is it's angles in a triangle add up to 180. So that's going to be 160 degrees. Make sure you state your reasons for every step of the working out, because there's normally quite a few marks for the reasons. The difficulty with finding the perimeter of this shape is we do have some of the lengths missing, so we're going to find the lengths that are missing first and then we'll find the perimeter. So the one on the right here is going to be the same as the one on the left, so this is going to be 5.6. Same with the one on the left of the 2.4, so this will be 2.4 here. This length here is going to be slightly more tricky to work out. What we do is we work out the total length across, or the total width across, which is 9.8, and we take away the bits that we know. So we take away these purple lengths at the bottom. So to work out the length of the missing bit, we're going to do 9.8, and we're going to take away the 4.3 plus the 1.2. And then when we do that, we do 9.8, take away those bits, we get 4.3. So this missing bit here is 4.3. So to work out the perimeter, we're going to start at the top left of the shape and add up all the lengths as we go around the shape. So 9.8 plus 5.6 plus 1.2 plus 2.4 plus 4.3 plus 2.4 plus 4.3 plus 5.6. When you add all those up together, you get 35.6. It's a perimeter, which is a distance, so our units are centimetres. We've got to first of all find out what the y-intercept is, and the y-intercept is just where our line hits the y-axis. So the y-intercept, which we sometimes can call C, is 11. Now, what's that 11? What units is it? Well, it's 11 pounds, because our y coordinate, our y-axis is in pounds. But what does that mean for the taxi company? Well, how many miles have been travelled on the y-axis? Well, 0. So at 0 miles, we've had to pay the taxi man or woman £11. So we know that therefore the taxi costs £11 at the start. We'll just leave it at that. Okay, so the initial charge, or the cost for the taxi turning up, is £11. So we know that the mean is the sum of numbers over the amount. But in this question, we're actually given what the mean is. We're given that that is 29. We're also given the fact that there are 4 cards, so we're given the amount. So what we can do is just get our lines in and solve this. So what we're going to do is just times both sides by 4. So we're going to do 29 times 4, which is 116. And so we know that the sum of the numbers will be 116. So all we need to do is to find the 4th card, is get that 116 and just take away the numbers that we know. And when we do that, we get the answer 26. Now you can easily check this by adding up 37, 26, 27 and 26 again, and then dividing it by 4, and you will get 29. First thing we need to do is work out the area of the wall, and so to do that we're just going to multiply the 44 by the 40. So 44 times 40 is 1,760. And next thing we notice is that each tin covers 10 meters squared. So it actually means we can work out the fact that there are 1,760 meters squared in total for our wall. And if each tin covers 10 meters squared, then we will need 176 tins. That's the amount of tins we need. And each tin costs £5.70, so it'd be 176 times the 5.7, or yeah, £5.70, or you could do it as 570 pence and convert it at the end. And that gives us a price of 1003.2. And so as money, that would be £1,003.20. We're going to start off by writing the numbers that the dots are at. So we've got minus 12 and we've got minus 5. And x is anywhere between those. Now, it's obviously going to be greater than minus 12, and it's going to be less than minus 5. But it can equal minus 12, and the reason for that is it's a filled in dot. But it can't equal minus 5 because that is a hollow dot. When we estimate, we normally round to one significant figure. So what I'm going to do is just rewrite this question, but rounding everything to one significant figure. But I'm just going to miss out this square root for now. So 3.3 would just be 3, and 4.7 would just be 5. Now, the problem with this 27 is square rooting 27 is difficult, especially without a calculator, and estimating should be done without a calculator. But if I round it to the nearest significant figure, if I round it to one significant figure, that will make it 30. Now, 30 is no easier to work out. So square numbers are a bit of an exception. When you've got square root, it's a bit of an exception. You've got to find it to the nearest square number. So 27 to the nearest square number is 25. So square root of 25 is 5. And then 5 take away 3 is 2. Times 5 is going to be 10. So our answer is 10. To work out the mass, we will need to find the density and the volume. Density is given to us in the question, but volume isn't. So we need to work out what the volume of this cuboid is. So the volume is just the 33 times the 7 times the 22. So that would be 5,082. And that would be centimetres cubed. And we need to write down the formula for density. So density is the mass divided by the volume. So rearrange this to get mass on its own, because that's the thing we're looking for. So mass equals density times volume. Density is given to us in the question as 2.1 grams per centimetres cubed. Times that by the 5,082 for the volume, and we get the answer of 10,672. And then that will give us grams, because our density is in grams, so that is grams, but the answer is asking for kilograms. So to convert that to kilograms, we just divide by 1,000 and we get 10.672. Then we need to round that to 2 decimal places, and so that would be 10.67 kilograms. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all, and that's what we call an outlier. So we know that these are going up in twos, so this will be 28. So the x coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. Now, between A and B, the shapes haven't changed size, so it's not an enlargement. They haven't rotated or they haven't mirrored, they've just moved. And the word we use for that is translation. So this has been a translation. And for a translation, we need to find out how far right they've gone and how far up they've gone. So we pick a point that we know on both shapes, and I'm going to pick the top left, and we count how many jumps we jump to the right. So 1, 2, 3. So we do 3 jumps to line it up with the other one. So there's a 3 at the top to say 3 to the right, and then we count how far up we have to go. So 1, 2, 3, 4. Now we've actually had to go down, and whenever you go down, it's like having minus up. Okay, down is minus up, so it's going to be minus 4 because there were 4 jumps. So we're looking to write a formula for the cost in pounds of hiring a microwave for X amount of days. So the cost is C, so it's going to be C equals, and it says it's going to be 55 pence a day. Now it wants the answer in pounds, so we need to convert this 55 pence into pounds. So that's going to be 0.55, and it's going to be 0.55 times the amount of days. Well, it says the amount of days is X, so it's going to be 0.55x. Then it says that there's just a one-off cost of £15, so you're going to have to pay £15 regardless. So we're just going to add 15 onto that. So the answer would be C equals 0.55x plus 15. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power of 16 times 9 to the power of 46. Now, when you have 2 powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62, so it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between 2 powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40, we just take away the indices. So it'd be 62, take away 40, which would be 9 to the power of 22. So our answer is 9 to the power of 22. When we multiply numbers, it doesn't actually matter which order we multiply them. So I can actually rewrite this as 7 times 9 times 10 to the power of 2 times 10 to the power of 9. 7 times 9 is 63. And 10 to the power of 2 times 10 to the power of 9, we add the powers, so it'd be 10 to the power of 11. Now here we've got a problem. It looks like standard form, but it is not standard form. Because standard form has to be a number between 1 and 10, but not including 10. And here we've got 63. So what I'm going to do is just quickly write out what number this is. So we've got the decimal point here. And you don't need to do this, but I find it a bit easier to show what we're doing. So here we've got 10 to the power of 11. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We fill these all out with zeros, and that's the number we've created here. A lot of zeros. Now, to make it a number between 1 and 10, not including 10, the decimal point, it needs to be here. So we want that to end up with 6.3 times 10 to the power of, well, let's work that out now. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 10 to the power of 12. Now you don't need to do all the working out I've just shown there. You just need to know when you convert that 63 into a 6.3, you need to add 1 to the power. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I go pick a point on my shape, and the bottom or the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.